some of the new systems and components you'll find on the Model 202, the new C-Class from Mercedes-Benz. We'll provide a brief technical overview of the key points as found in the Model 202 Introduction Manual. For a more detailed description, you should refer to the Introduction Manual. Also, before viewing this program, you should view the first video in the series, Model 202 Engineering Overview. This will answer questions you may have on the basic design of the vehicle and major systems. The third program, which will follow, Model 202 Disassembly Procedures, will complete the introduction series of videos for the 202. It will show you some of the disassembly procedures that are unique to the C-Class vehicles. To help you reference the information you're about to see, we'll follow the Mercedes-Benz group system sequence as found in the Introduction Manual. You may want to have the manual at hand and stop the tape and review specific points in more detail as you feel necessary. The first, and possibly most important point to cover, is the location of diagnostic information in the Mercedes-Benz service literature system for the 202. Diagnostic information will be included in the existing set of diagnostic manuals, which will be expanded by including Volume 2, Chassis and Drivetrain. The Maintenance Manual, Volume 3, will now include the 202. And 2 new electrical troubleshooting manuals will be added that will cover only the C-Class. And of course, the service microfiche will be expanded to include Model 202 repairs. Keep in mind that the 202 Introduction Manual includes a survey of where each system is found in the diagnostic manuals. Both the 4-cylinder 111 and 6-cylinder 104 engines used in the Model 202 incorporate the hot film sequential fuel injection, or HFM SFI, introduced in the 124 series beginning in 1993. There are several refinements to the system as used on engines 111 and 104, such as an expanded onboard diagnostic system for monitoring emission-related systems, referred to as Onboard Diagnostics 2, or OBD2, an electric air injection pump used in place of the usual belt-driven pump, and finally, a second oxygen sensor located after the catalytic converter. The purpose of the second oxygen sensor is to monitor the efficiency of the catalytic converter and the function of the oxygen sensor in front of the converter. Before beginning an explanation of the function of OBD2, it's important to know that a detailed description is not included in the Model 202 Introduction Manual. Instead, the description is found in the model year 1994 Model 124, 129, and 140 Introduction Manual, since OBD2 is also used on the 6-cylinder engine found in the S and SL 320. The Model 202 Introduction Manual only covers the specific differences in OBD2 that apply to the C-Class. Onboard Diagnostics 2, which in effect refers to the diagnostic module N59/1, is a substantially expanded version of OBD1, as used on 1993 model year vehicles having a check engine light. With the OBD2 system, a total of 63 tests are performed, and failures are recorded if they meet certain predetermined conditions. If the recorded failure may be critical to vehicle emissions, the check engine lamp is activated. When a legitimate fault does cause the check engine lamp to come on, the diagnosis begins with the handheld tester, the appropriate tester module, and the multiplexer cable originally introduced for the Model 140. The listing of DTCs for the diagnostic module is found in the Introduction Manual for Models 124, 129, and 140, and in the Diagnostic Manual, Engines, Volume 3, Section 8. Let's take a look at the handheld tester program for the diagnostic module and point out some of the unique features of this test sequence. Engine shows a fault, so we'll access that menu. Since HFM, SFI, and diagnostic module both show faults, you would logically read all trouble codes in both systems and record them before proceeding. But we'll access only the diagnostic module, since our interest is in the new information available in this system. The function menu is displayed, and DTC memory is selected. The DTC screen displays three choices: current DTCs, registered DTCs, and stored DTCs. Current DTCs are trouble codes for problems that are actually present at the time the tester is reading the codes. Registered DTCs are trouble codes where only partial requirements have been met for recording a legitimate fault. Stored DTCs are those trouble codes that relate to faults which have recurred a specified number of times and have also met other requirements that identify it as a definite problem. Where applicable, a stored trouble code activates the check engine lamp. Let's enter the stored DTC screen and go through the new readouts and their significance. The first unfamiliar thing you will notice is a 3-digit code on the left. These are special factory codes that do not apply to testing at the shop level. The trouble codes we're interested in are in this column, and you'll notice that the diagnostic module codes have 5 characters. The first 2 characters are always either a P0 or a P1. The significance of the P0 and P1 relate to regulatory requirements. Those regulations provide a time period within which new vehicles must be equipped with a standardized diagnostic plug for connecting a generic scan tool. Specified faults can then be read by any service facility using the scan tool. If the trouble code is preceded by a P0, it is one of the faults that can be read on the scan tool. If the trouble code is preceded by a P1, it is an additional trouble code that is only readable using the HHT. The ability to read the additional trouble codes expands the diagnostic capabilities of the Mercedes-Benz dealership's service department. The F1 and F2 buttons at the bottom of the screen activate new functions in the diagnostic module program. If printer capabilities are installed, the F2 button will operate the printer, which will print a paper copy of the screen being displayed. The F1 symbol and button access what is termed as freeze frame data. Briefly put, the freeze frame data provide the history of what was happening when the problem occurred. Let's take a look at the freeze frame screens. The first screen displayed is always the initial data A screen, and the data A screens document the conditions the very first time the problem occurred. The first screen provides 3 lines of information. Fault frequency, which will always be a number 1 on the first data screen because, as mentioned, the conditions when the problem occurred the first time are documented on the data A screens. Trip length, or distance driven from the time the engine was started until the problem occurred the first time. And time since start, or the elapsed time from engine start until the problem occurred the first time. In this case, both screens display zeros, indicating that the fault first occurred on starting the vehicle and before driving off. The next screen continues with the engine speed when the problem occurred the first time. Throttle valve angle at the first occurrence, the coolant temperature, manifold pressure, vehicle speed, and so on, through 3 more screens of information that document exactly what the conditions were when the problem first occurred. As mentioned, the screens initially displayed will always be freeze frame data A, documenting the first time the problem occurred. The F4 button is designated for accessing the data B screens, and the B screens document the conditions present the last time the problem occurred. When the problem occurs again, the previous, last time, is erased, and the data related to the most current occurrence is recorded on the data B screens. The automatic transmission used in Model 202 is the familiar type 722.4. The transmission engages first gear at standstill and on takeoff. You'll find a shift point chart in the introduction manual to assist in diagnosing shift point complaints. Although the need for camber and caster adjustments during factory production has been eliminated, if a subsequent measurement should indicate that either adjustment is out of the specified tolerances, a correction is possible using a repair version screw and washers. Up to July '93 production, the control arm mounting hole is oblong, and a repair version mounting screw is available that is designed using offset tab washers. Depending on the position of the tab in the oblong slot, the lower control arm is moved in either a plus or minus direction. That applies to both adjustments, camber on the front bearing and caster on the rear bearing. Beginning with August '93 production, the oblong mounting hole was changed to an indented hole. The repair bolt and washers are modified to match the indented hole, but the principle for performing the correction is the same. A chart is provided in the introduction manual for plotting the required correction. Both the anti-lock brake system and the acceleration slip regulation have diagnostic trouble code readout capabilities built into the modified control module. In addition, the ASR system used on Model 202 is a modified version of the ASR version 3 as used on Model 140 and is identified as ASR 4. There are several modifications involved with ASR version 4, but the most obvious is the elimination of the pressure reservoir used with the previous ASR system. Eliminating the pressure reservoir was made possible by installing a larger charging pump with increased performance, making it unnecessary to store pressure. An important repair point related to ASR4 is the elimination of the bleed screw, since the ASR4 hydraulic unit has a self-contained, closed bleeding system. The bleeding procedure is accomplished electronically using the handheld tester. The procedure is found in the diagnostic manual. For electrical connection to the steering wheel, instead of slip rings, the horn and airbag on Model 202 use the clock spring, introduced during the '93 model year. If the steering linkage is disconnected, the steering wheel must not be turned, since this can destroy the clock spring. The drag link and tie rods are in effect one piece, connected by ball joints. Due to this arrangement, toe-in is adjusted by loosening only the nut at the outer ball joint and turning the tie rod at the hex provided. To provide for the pass-through feature and fold-down rear seat backs, the fuel tank is located under the floor in front of the rear axle. Mounting the tank in front of the axle requires a unique two-chamber design to provide for the drive shaft. That in turn required a unique system for connecting the two chambers to allow fuel delivery from the left chamber to the single fuel pump outlet at the right chamber. To accomplish this, a Venturi system installed in each chamber uses the fuel returning to the tank to create a siphon effect. There are several significant changes in the body and accessory system. To begin with, there are 3 battery positive cables. The small black cable feeds the rear fuse box. The large black cable is routed on the left interior of the vehicle and supplies all consumers except those fused at the rear fuse box, and the electronic control modules in the right side of the component compartment. The large cable terminates at connector X4, and the alternator and starter cables connect at this point. A capacitor is included at X4 to suppress electrical interference from the battery cable. And finally, the third cable, the small red battery cable, is routed in the right wiring duct and supplies only the control modules found in the right side of the component compartment. One of the modified systems is the exterior lamp failure monitoring. Unlike previous systems, the high beams and turn signals are not monitored since a failure is relatively obvious. The convenience control module is located in the trunk behind the battery. It provides one-touch opening of the windows at both front doors and closing of all side windows and sliding roof if the key is held in the locking position. Unlike Model 124, the convenience feature is electrically independent of the central locking system since 2 wires are used on the micro switches for providing the opening or closing signal instead of the previous single wire. The pneumatic system control module and pump assembly is located in the trunk. There are 2 different version pumps available: the standard version and a version for vehicles with multi-contour backrest. The system provides pressure and vacuum to operate the central locking, vacuum assist for the intake manifold dependent climate control system, and pressure to operate the multi-contour backrest. A transparent line from the trunk delivers vacuum to the distributor block, which serves to maintain vacuum in the air conditioning vacuum reservoir if the engine vacuum is insufficient. The air conditioning vacuum reservoir is mounted in the right front wheel housing. Door plug connectors for the pneumatic and electrical lines are similar to those found on the Model 140, with the exception that a hook is used to unplug the connector. A disassembly tip to keep in mind is that when removing the protective boot, look for the 2 markings which locate the hidden securing tabs. The central locking can be activated using the interior control switch. If the alarm system is armed, the LED in the switch blinks. The new radio is a one-piece unit with an integrated faceplate that is not removable. The antenna has the operating electronics in a separate housing. And if the Bose sound system is installed, the audio power amplifier is mounted in the trunk. The anti-theft alarm system of Model 202 differs from Model 201 in that it has a modified control module with only 1 connector. The parking lamp circuit is activated when the alarm is tripped, and the starter lockout relay that interrupts the starter circuit when the alarm is armed is mounted by the parking brake pedal. The 202 alarm system also includes trouble code memory for diagnosis with the handheld tester. The climate control is considerably enhanced in comparison to Model 201 and is similar in principle to Models 129 and 140. The key differences include a dust filter with 15,000-mile replacement intervals and diagnostic trouble code memory for diagnosing system faults, either by using the temperature display or with the handheld tester. For the first time, the push-button control module includes the drive belt protection circuit for compressor cutout, rather than using a separate cutout module. Since the push-button control module is a universal version for all 202 models, and each model has different belt drive protection parameters, A new push-button control must be programmed to the vehicle at installation. The programming is done very quickly with the handheld tester, or it can also be done directly with the push buttons. The procedure is found in the diagnostic manual, Climate Control. As standard equipment, the 202 is equipped with emergency tensioning retractors on both front seats, a driver's side airbag, and a passenger side airbag. All connections for the ETRs and airbags are equipped with a shorting bridge. The bridge short-circuits the triggering circuit when the plug is removed, making it unnecessary to disconnect the battery for repair work that requires only the removal of the airbags or ETRs. As a precaution, the key must be removed from the ignition during these types of repairs. If welding on the vehicle, the battery and SRS control module must still be disconnected, as previously required. Since the SRS is now tested using the handheld tester, the test connection as used on other models has been eliminated. This concludes the brief overview of the technical features of Model 202. As mentioned previously, a detailed description of the subjects covered and the many other features not included is found in the introduction manual for Model 202.